Toy. Dank u wel. Thank you all, and thank you for being here. Yes, I am here because I'm on a quest to make better software for humans, better software for machines, and so far I failed. So I hope that maybe you can help me through this session and help me with some of the pain and suffering that I've experienced in my career. Maybe you've experienced similar pains and similar suffering. But of course, recently there's been a massive change in our industry. So with the advent of artificial intelligence, I hope that we will finally solve some of our problems, maybe have a bit of focus on actual natural intelligence as well. And of course, the clicker always starts out failing. No, there we go. So my daily mission, as I'm sure is true for many of you as well, is to help people deal with less paper. So I took out a subscription to DALL-E just for these wonderful pictures, where I asked DALL-E, please give me an old school office before we had computers, before we had all this artificial intelligence helping us. And I asked for, give me an office with a lot of paper and old school desks, and they gave me this one. And I felt like, this one, it's got a little bit of weirdness in it, so I asked for one with fewer phones. Have you seen those people trying to ask DALL-E for a room with no elephants? So I've given it a couple of attempts, but I actually just used the first picture because every attempt got increasingly more and more phones. Yeah, maybe there's some work to do in that area. Of course, there's plenty of work to do for us as well. We write software, that software automates, hopefully making people's life easier. So that's what we'll do today. We'll take a look at what some of these people could be doing and how we could help them, how we could automate them. We'll focus on a very simple little bit of problem that we hope to help them with. Now, imagine if these people are selling products, just products, and we are going to write a little script for them, a little tool, a little app that will help them synchronize stock and pricing between their supplier and themselves. That's going to be the subject that we will work with today. So we could write a little script that would do something like this. It would find all the products that we need to report on those products, mark those products as being reported. Now what we'll start out with is a very untypical Laravel eloquent kind of approach. I am not the best Laravel developer there is, so I'm sure if there's Laravel developers in the room, you'll have something to remark. But here is the first version of what it could look like. It's just a starting point. We'll use this to continue from and have our conversation. So take a moment for this little piece of code. Absorb it. What do you see? We will go through it line by line. So the first thing that caught my eye when I put this away for 6 months and then look back at it is we've got our static call to a model. It uses a cursor, so that means that we are safe against batching operations, safe against having too much data to work with. But yeah, it is a static call. I'm sure we have some opinions on static calls. Yeah. The second thing, we have our client injected, and we call the report method on that client. Does some work for us. Nothing too crazy here, I don't think. Of course, that client could be down, so we have to make sure we catch that exception and that we translate that to a proper domain level exception. We don't bubble up exceptions now, do we? Usually. And we have a little bit of model access, direct access to property. We don't inject the date, we just get it. Is that good? Is that bad? I'm sure you'll have some opinions on this as well. And finally, of course, we have to make sure the model is actually saved. We save on a single product basis instead of batch saving. Is that a good idea? Why not?
Depends.
It depends is very 2018. What would it depend on?
Maybe there's something why you want to save on the products. Normally, I would say no. But
Yeah. Yeah, there's a bit more information that we could put in there. For now, I think the reason that we have just our singular call there instead of doing more batch-oriented operation is that this script could crash at any time. It could pick up and continue where it was. I think that's a nice property to have. What kind of test cases would we need to cover this code? Any suggestions? Just yell. A test case for the exception, a test case for the try part. Maybe for the saving, definitely something maybe. And one for getting the data, or particularly one for getting that there is data that we don't have to use. Everybody with me? So which test cases? Definitely the one where we do have to do something, the one where we don't have to do something, but there is data, the one where it goes wrong, and maybe, my clicker is not helping me out. Maybe if I do it like... Okay, so I'm just gonna have to stand like this. Is everybody, yeah, if you like old school, you have the television where you hold it like this. Cool, yep, so these test cases, I'm breathing into... Can you still hear me? You have to deal with it. Kevin, can you help me out for a second? Thank you. So, should we test when the database is down? Generally speaking, the type of apps I work in, if the database is down, I'm in worse trouble than not having a test for it. So generally speaking, I skip that one, but you could have it. All right, so here's a test that captures that the reporting is working out for us. We expect that there is going to be a call to the client, and we assert at the end that the product was reported at. How do we feel about expects once? Do I have an opinion on that? It's good. It's bad. Who feels that's a good idea? Who feels that's a bad idea? Yeah. And a lot of people are like, I'm just going to wait until you say something. Yeah, that's fine. Sorry? So that's a very interesting remark. What if this happens in a loop? What do you mean expects once? Yeah, we definitely do rely that there is an empty database at the start. So there's a little bit of implicitness in there, so yeah, good guy. Generally speaking, I would say at least this locks down the behavior of the application, so that's nice. Maybe there's some consequences to these kinds of expectations that we don't like, but maybe we'll run into that. So this one, it does work. Let's say we have nothing to report on, so in that case we expect it to be called never. Okay, makes sense. Mm-hmm.
No, this one is clearer. Like the last one was once, but you may want to have a data provider or whatever that does that.
Yeah. But we have to start simple, right? Yeah. And finally, let's say the client does not report back to us. We have to make sure that we translate that exception. All right. So this is an overview of what we've created so far. The subject of today is not testing, but I just want to point out, if you use PEST or you use PCB Unit's test docs option, you can get this little overview of what you've built so far. And I like to use these kind of test naming schemes to make sure I can document almost like the behaviors, the capabilities, responsibilities of my object. If you're interested in that kind of stuff, definitely check out Kevin and Henny. Worst clicker ever. So this kind of code, this is legacy typical for me. Is this kind of code something you run into daily or something that you run into only on tickets? Or like, how are we feeling about this? Is this more or less average for you? Quite worse than average? Quite better than average? It's okay. It happens. Cool. So what is the goal of the developer writing this code? What was the developer's goal? Maybe, who knows? Was the goal to capture intimate domain knowledge? Maybe. Marketing. Was the goal to leave an expressive solution for a developer to get back into 6 months later? Possibly. Was the goal to finish the ticket? Yeah. So this is our subject for today. We've got this piece of code. So when I talk about what was the goal of the developer when they wrote this kind of stuff, what was the goal? Well, when you write code, you make choices. You make choices all the time. Like there's a choice to do it like this. Maybe it could have been different. It could have. All those choices have consequences. And some of those consequences we like, some of them we don't. And that's what we'd like to get into today. So those consequences, the ones that you like, the ones that you don't like, we call those trade-offs. Do you typically think a lot about trade-offs when you're coding? I see a lot of people nodding. That's really good to hear. So what kind of trade-offs do you typically make? Any particular decisions that you always favor in a particular direction?
Simple first.
Simple first? Simple first and then?
Complex later.
Complex later. Nice, I like it. Performance? Always performance first? Trying to. Yeah, I think over the years we've had a lot of cool acronyms for things that we could use in trade-offs, things like solid or dry. Yeah. So for this code that we just had, what are some of the consequences of that kind of code? Well, kind of hinted at, maybe for maintenance, you could maybe not get back into it as easily 6 months from now. One particular trade-off with this kind of code, I find, is, for example, as was mentioned in other sessions, slow tests. This style of coding relies heavily on database testing. That doesn't have to be a problem, but until you get a lot of this kind of code, then maybe it starts to become a little bit of a problem. So, one typical approach that we could take into fixing this is to not rely on the database, but maybe inject a repository or something like that. Of course, that's another principle that you could use in trading off, which is no problem cannot be solved by adding another layer of indirection. So of course that would mean we would have to inject some kind of repository, so use dependency injection. Does anyone know the difference between dependency injection and a dependency injection container? Is this an example of dependency injection or dependency injection container or both? This pattern is called, maybe some of you have heard of it, service location. We do inject something, but what we inject is not what we mean to inject. In my previous company, and I have some old colleagues in the room, we used to call this the suppository pattern. You just shove it in and take out what you want. And is it important to know that kind of stuff? Well, no, not really. Like, is it important to know what service location is? No. But sometimes it's really nice to know these kinds of patterns because, history tends to repeat itself. And if you know your history, you know your patterns, then maybe you don't make the same mistakes that people in the past have already made. Cool. So what we're going to do is we have this repository now injected. In order to create a test for this, we can create a mock. And then we can change all the tests to unit tests. And that's really fast. Should we still keep an integration test? Who feels like we don't need an integration test once we've got everything covered with unit tests? Who feels very strongly that we do need an integration test? Hey, I see you've all been on the internet. Maybe having some idea of how the things cooperate and work together is good. Has anyone ever seen one in real life? too many times. Too many times. Yeah, it's really good. The unit tests, they're good. They help us to understand the components, but it's still good to have the integration tests to help us understand how the system behaves in full. Cool, so we've got our bases covered. We've got a couple of tests that help us to understand the particular behavior. We've got a test to help us understand the whole. I like this kind of testing setup. It gives me a lot of confidence. For full confidence, you should, of course, all do mutation testing. Has anyone heard of mutation testing? Nice. I don't get affiliate, unfortunately. This talk is not about mutation testing. So we inject the repository. We expect it to be called, and we're very happy. Expect the client to be called, and then we're very happy. So this makes sure everything works together, and of course the other test now makes sure that the different parts work. This is quite a bit of setup code. Who uses mocks regularly? Mocks with these kind of expectations? What do we feel about mocks? Boo. Necessary evil.
Acceptable annoyance?
Acceptable annoyance? I feel like that's the fairy tale version of... No, wait, fairy tales are... Acceptable but annoying. I like it. Yeah, so we've got more setup now. Our code is kind of like more decoupled. It's decoupled at least from persistent concerns, but still, yeah. So how do we deal with this kind of mocks? Like, let's say you have to write 30 of these kind of tests. What do you do? Factories? ChatGPT. Do mine before you get all kinds of phone calls in there and So one thing that's interesting is I've done my fair share of testing workshops, and every time I do the testing workshops, when we get to the stage of copy it once, copy it twice, everybody goes, aha, and then they create a builder or a factory method for this setup. And then I started doing these presentations, like practicing, make sure I do my best for you. And then everybody started yelling, use in-memory variants and that kind of stuff, because I had this wonderful picture prepared. And then nobody offered builder methods. But of course, builder methods are the right solution. Maybe they are, maybe they're not. Builder classes. I'm sure that will fix your design. Yeah. So at one point, when I was feeling very arrogant, I figured, I'll just write a keynote. I'm never ever going to get a keynote position anywhere, but I figured I'd just write it anyway. And I won't do the whole keynote now, but it was going to be about pain and discomfort and how we can use the information that comes back at us to make maybe some better decisions in the future. So there are two kinds of discomfort for the purpose of this conversation. The first kind of discomfort is painful, it's sharp, it's very immediate. So you put your hand on fire, and there's, ow, oh, that's very sharp. Oh, I had a cut somewhere that I didn't realize it gets sweat, and it's ow, ow. Or I stand on my ankle that was busted, that's very painful. And it tells you immediately, like, oh, stop doing that. But then there's this other kind of discomfort that kind of like creeps up on you over time. So will come up to you like boredom or anxiety or concern or worry or And when you start to get that kind of discomfort, it's not like you can stop doing what you were doing a second ago and it's gone. You need a different way to deal with it. So when you correctly diagnose what's happening, you can correctly apply a remedy. And if you do mocking, for example, I feel mocking is very often like aspirin. It suppresses the symptoms, but does it really fix the root cause? Does it really fix the problem? So this code, how do we diagnose this code? What's happening here? Why do we mock when we have this code? So let's get back to some basics. What is a function even? Weird question.
Functions is something that can be done over and over?
Yeah, definitely. Definitely. And moreover than that, it also takes some information in and hopefully puts something out. Otherwise, why would you be doing it over and over? So when a function executes, hopefully you put something in, you get something back. It's very useful to us. Sometimes we get an exception. Is this everything that functions do for us? Would he even ask the question? So what else is happening? There's something coming into our functions and going out of our functions. And I'm sure you've all glared at the title of this presentation, so you have some idea what I'm getting at. What's that other one? State, yeah. The application state. I like to call it context, but there is something being pulled into our function. The parameters are assessed against it. Some stuff happens, some stuff, and then hopefully a return value, or something like that. So another way of putting it a little bit more sensibly and with more arrows could be this. Typically, a function will take in parameters, and those parameters need to be assessed. Are you giving me something sensible? And you could call that syntactically correct. Are you even speaking language to me? This is the space where you typically convert things to like value objects. And then, once you have that incoming message understood, then you have to hold it against the system's current state, against the context of the system. Yes, okay, you're speaking language to me, but what you're speaking to me, does it make sense with what I already know? So for example, let's say delete user 17. That may be syntactically correct, but if user 17 doesn't exist, then it's not semantically correct against the system. Or even, you could say delete user minus 17. That's likely not correct. I don't think we even have to check the database for that one. Does that make sense so far for everyone? All right? So we typically use exceptions for all those, for both cases. Something is syntactically correct, we'll throw an exception. Something semantically correct, we'll throw an exception. But of course, the real shine for exceptions is when, for example, that client was down. That is exceptional. Is it exceptional if we don't have user 17 in the database? Is that really that exceptional? Yeah, it depends. That's the consultancy rate going up. Yeah. So we'll not get into exceptions too much. We really want to think about these context and side effects. Context and side effects. If we hold this against the little bit of code that we had, we might have some new insights. We correctly identified that, yes, we have a problem with loading this database products in, but we replaced it for a different way of loading in context. So yes, we solved the database issue, but we didn't really solve the function issue. So you could say, this is where we start putting in context. And this one is where we start creating some side effects. Here is where we throw an exception, obviously. There's a bit of context that we're pulling in here, which is
The last reported as if it exists at all.
it's the other one, the date.
It's a date.
Yeah. Date, time, file, all this kind of stuff that you sometimes just assume are there. They're all context. And of course, finally, the side effect of saving. So it's just a couple of lines of code, side effects, context. Of course, this code isn't necessarily doing that much logic, but there's still a lot of stuff happening. Anyway, let's take a little bit of a break. Do we have any car people in the room? Car people. People who like cars. Not people who are cars. Which car is this? It doesn't exist. Yeah, this is some syntactical and semantical error. But if you like really squint, which brand car would this be? BMW? Yeah.
No, it's a BMW Mercedes.
It's a BMW. Something like that. Okay, let's try it again. This one. Which car is this?
Your car.
It definitely is. It was. But which is this?
Z4? 5? 3?
Yeah. This is a BMW Z3 convertible. Yeah, we did have this one for a while. but we didn't use it that much, so we ended up selling it. My friend has this car, and he still has it. Which car is this?
Oh, is it C240 something?
Yeah. Yeah. Probably a lot of you know more about cars than I do. For my understanding, this is a Chevrolet Corvette, a C4. This should be the 1994 one. My friend has the 1991. Which car is better?
That one.
Which car is better?
You are on what you are.
In what way?
Depends on what you want. Yeah, there's only one like really major difference. They're both convertibles. If you get the luxury variant, they're about equally as fast. The only difference is that one is a European and that one is American. So if you want to go straight, you take that one, and if you want to actually be able to, okay. When I first got the car, a lot of people started honking at me, and I was like, "Yeah, oh, you're all jealous." But it turns out my tail light was broken. And I had to replace it. And I did end up doing it myself. I have the full set of steps needed to replace the tail light on the next slide. Maybe you should all zoom in a little bit so you can all see the steps. You ready for it? Here it goes. In order to replace the tail light, you just unscrew it, put the different one in, and just screw it in. You don't even need a tool. It's just got this, you can do it by hand. Yeah. What was the goal of building this car? What did the engineers have in mind? Yeah, they weren't thinking about all the garages that need to get their hourly rating. Yeah. My friend had a little bit of an experience, let's call it, with his car. He had to replace the antenna. I found a video on YouTube. It's 12 minutes and 20 seconds. And the guy that does this starts with, "I'm lucky because the exhaust and the rear wheel are already out." What was this car optimized for? What was the goal of the engineers? Someone else's money. Yeah. Because of course, it could be a side. Yeah, it's a little bit facetious of me, of course. Yeah, cars. Anyway, this was totally random, had nothing to do with what we were talking about. So we had this piece of code, and it had some context, and it had some side effects, and all that kind of stuff. So what do we do? Oh yeah, this was the original, and this, of course, with repository, didn't really help us. It helped some, but it gave us different drawbacks. So if we take this into consideration again, if we take these different steps that go through a function and make them explicit, and we can turn it maybe into a little bit of a model that we can aim for. So we have, of course, our parameters, our return value, of course, exceptions as well, but we kind of want to get rid of those context and side effects. So what we could do is model it slightly differently like this. There is like that break-off point where we go into doing something useful, and then we come back to our original and do all the side effects again. So if we put this a little bit more neatly, we get something like this. Function B now becomes something that we don't have to mock for at all. What do you call functions like function B? Pure functions. So this setup, it allows us to fully unit test function B and integration test function A. If you use PHP Storm, it will actually suggest the pure annotation. I don't know, has anyone found that useful? I'm not sure yet. Sorry? Sounded for ages? Oh, Psalm, yeah, of course. Yeah, of course. Yeah. 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 So what we could do, let's just start with something small. Let's take this this little bit in here. Let's just focus on getting rid of this context and side effects from the repository. So typically speaking, when you get into the situation where you have to mock or you have to deal with, you take the part that is annoying you out and then you replace it with something else. And that's kind of like not, it helps with the specific thing that you have in mind, but it doesn't help with the overall architecture of getting to that space where you don't need to mock and don't need to database test and don't need to. So we're going to take this inner loop and we're going to take it out and put it into its own space, away from the side effects of the repository. Of course, this is not a very impressive step. And there's still issues left in the function that we extracted, but we have narrowed the scope now. For testing a single product, we don't need to mock the repository anymore. So for our next step, we should probably take out the remaining side effect of the report call. But that's not very exciting. So we'll add a little bit of excitement to our little app. So instead of just doing it like this, we'll add a little feature request in. Let's say, rather than just reporting, we actually do take some information back. And depending on what comes out of that reporting step, we decide whether we should update the price of the product or whether we should take the product out of circulation. So if we go back to our requirements, we add these two requirements in. If the report comes back with a new price, we update the price, and elsewise, we take the product out. So with where we were, we could add that in as this piece of code. We just add that little bit of behavior there. We capture the response, and based on what the response contains, we decide to update. I hope this clarifies a little bit more how those contexts and side effects can influence the cleanness, you could say, of the code, the purity. And we can add some arrows to make that clear and highlight this. We have our context at the end, of course, still. We have our exception still, and our first call to the client now has side effects as well as context. So we're going to need 2 test cases for the 2 new behaviors that we're expecting. We are going to need these 2, make sure that we can deal with the new price and make sure that we can deal with whether the product should still be in. And we can create a test to verify that we can update that price. We just make sure that the client returns the correct response, and we can assert that the product is correctly updated. And of course, if the client returns false, we also want to make sure that our product is no longer active. Now you can imagine as the complexity of these kinds of situations start increasing, that this approach and this way of thinking starts to become more and more useful. So how do we deal with this? Well, as we said before, there is no problem that cannot be solved by adding another layer of indirection. We take out the pure part, pure-ish, not pure yet. And we call it from the original space. And I think by this point, you've all caught on that the title of my session is a bit of a lie. We're not really like pushing side effects to the edge. We're like pulling logic further inside. Yeah, potato, tomato. The test for this one, we make sure that the first case where the price needs to be updated is solved for. There's no more setup. It's all gone. And in the second instance, again, no more setup. So what we're doing here is we're trading the complexity of our test cases, the complexity of particular pieces of code, against the global complexity of having more files to work with. Our test suite ends up looking like this. And you can see that, it's more tests. We are covering, of course, a little bit more with the increased feature request. But this gives us a lot of confidence that the separate parts of our application, which are tested very quickly, are all in order, and of course that the integration and the database all work together as well. If we were to map out everything that happens here, you could visualize it like this. We've got a couple of calls that all are side effectful. Of course, we didn't really finish our purity in the final part, but it's pure enough for our purposes. So if you imagine that we started at the bottom right, it still feels like we pushed our side effects to the edge. So is this useful? Is this a good idea? Was this worth it, this trade-off? Depends. It depends. A lot more files, a lot more functions, a lot more tests. Was it worth it? Well, in this instance, maybe not so much. It's just a contrived example. But imagine your app looks like this. Would you have all those green ones be red? Or would you have 3 less green ones and all of them be red? As you start to increase the complexity of your apps, this approach will be more and more worth it. It will give you more and more benefits and fewer drawbacks. So typically speaking, a lot of us do a lot of work with get some information from a request, put it into a database, get it back from a database, put it on a screen. Don't use this. It's not going to help you. But if you get into situations where you got a bit of complex logic happening, if this happens, then that happens. Oh, also that has to happen. Oh, that and that. Then it starts to become more sensible. Complex calculations, that kind of stuff. This is where this approach shines. And in that sense, that's kind of what I want to give you today. This is not the approach that you should be using. If you've used this before, awesome. If you haven't, maybe it's a new tool that you can put in your toolkit and that you can start using when it makes sense for you. Because the more tools that you have, the more different situations, the more different options you can provide and get different pros and cons. If you're interested in this kind of stuff, here is some further reading. The first one I'd hoped to put into this presentation, but I feared I'd go over time, so I left it out. The integration operation segregation principle, it's a mouthful, but it's a different way of looking at the single responsibility principle. Single responsibility principle is, I think, useful, but it's difficult to use in practice. It's easy to have arguments over. Well, I think this is single. Well, I think this is not a responsibility. Well, yeah. The integration operation segregation principle by Ralph Westphal is a different way of looking at it with a more streamlined, cooperative approach that you can use in practice. The other two, railway-oriented programming, there's a couple of very interesting sessions on YouTube on that one. Highly recommended for you to check out. Mostly deals with exceptional cases rather than what we talked about today, whereas the other one, functional core imperative shell. Has anyone heard of functional core imperative shell? Oh, very interesting. It's old. I don't think it really caught on that much, but it's definitely an interesting resource to read up on sometime. Cool. Let's summarize for today. I should have put those on there as well. Let me just and read them all for you. So all the design that we do, it's optimized for something. Whether we make choices deliberately or not, we get into a situation where we have drawbacks and benefits. And it's going to be good for a specific situation and bad for other situations. And the degree to which it's for the correct something means the design worked and it achieved what we wanted to achieve. We can sometimes feel, experience, get from our CI that the design is not working out for us. And when that happens, we usually find those in things like inverted test pyramids. Has anyone, do you all know what an inverted test pyramid is, or an ice cream cone testing pyramid? That's a wonderful thing to Google, definitely. But in short, when you write tests for your application, typically speaking, you'll have very few end-to-end tests, which is like the tip of the pyramid, and then you have a bunch more database and integration tests, and then you have a very strong, wide base of unit tests. This is the approach. What we talked about today, that's the approach to get to the testing pyramid. Having more integration tests and fewer unit tests will get you the diamond, and having mostly end-to-end tests will get you the ice cream cone. And those can be fine for you. And it could also be that maybe it does become a CI problem or a feedback problem. If you are experiencing discomfort with those symptoms, then that's information. It's a signal, and you should act on that signal. And that signal might tell you, just use aspirin for now. For example, just use the repository, get into a state of integration testing, but not really actual unit testing with lots of mocks. It's fine. If speed of CI is what you want, the repository approach is fine. But it's not a root cause fix. And context and side effects do explain, in this instance, the root cause fix. pure functions being the counter. And what I'm really trying to say is don't choose your approach. If you have only one tool in your toolkit, it's just going to be what you want it to be. But if you have multiple tools in your toolkit, if you know how to do CRUD, if you know how to do DDD, if you know how to do functional, if you know these different approaches, then you can choose what the outcomes of your design should be. And then you know which approach should follow. All of us are problem solvers. We love problems. Sometimes the problems that we solve are really big. Should I use Kafka? Should I use Rabbit? Should I use event sourcing or not? That can be really big decisions. But during our day, as we code, there's a lot of little decisions that we make. And those little decisions add up. They influence over time how our CI runs, how maintainability works out for us, how other programmers experience us. So don't discount those smaller choices. You don't want the consequences of your choices to be a side effect. Thank you.
Thank you, Pim. If there are any questions or people want to... All right, I'll get to you.
It's always the one.
Thanks for the talk. It's really, it was really interesting approach. One thing I was wondering, you mentioned that the trade-off of pure functions is you get a lot more files. I got that argument from my manager a few days ago. Oh. And do you have any tips on how to deal with a lot of files?
I was expecting the manager questions, like just fire the manager. No. Tips of dealing with lots of files. Well, again, it's a trade-off. So anytime you're going to apply modularization and packaging, you're going to have a structure with directories and files in there. Coding complexity has to go somewhere. And if you have a whole bunch of files that are very, very, very tiny, you can definitely... sometimes you can, sometimes you can't. No, but it
If it's about files, just put all your classes in one file.
Of course, it's not about files. So typically speaking, when you have a code base, you can plot out the number of changes that files experience versus the complexity of those files. That is a really good plot to make on your code base. If you have a typical code base, it should look like a 1 divided by x graph, and then there's going to be a couple of dots on the top right where all your dragons are. If your code base looks more or less like that, then your manager should have nothing to worry about. Because your manager is worried about something, like just a number of files, as the gentleman in front is saying. There's something behind it. What are you worried about? What are you worried about? Is it that maybe new devs can't follow? Well, if you have a whole bunch of files in a couple of directories that no one ever visits because they're right, they're well tested, and no one has to touch them, it's not an issue. But if you have a lot of complexity in a few files where everybody has to go all the time, that's where your manager should be worried about. So talk to your manager about costs. What does it cost us to have these files versus what would it cost us to have fewer files, different files? Does that answer your question?
Yes, yes, thank you.
All right, any other questions? All right, anybody here? No? No? Okay, you're going to make me walk down and then you're going to bring me back up. I just know it.
It's good for your health.
Yes, thank you.
Hello, thank you. My question is about your presentation itself. So why you've chosen this old New York office backgrounds? I cannot understand the relation with the
it's from the very first, it's about working with people and paper and automation. It was thematic, I hoped.
Thank you.
Thank you.
All right, other questions? Okay, you can ask from up. I knew it.
One follow-up question. Did you ever work in a project where you combined multiple approaches, where you have like the DDD variant with pure functions and also CRUD for like, this is simple use cases, we're never gonna...
Yes.
Did it work out well, or is that something you're like, don't do it?
It worked well in the past across modules. We currently have one module with a mix, and it's kind of too early to tell.
Okay.
I am not happy with the mix, though. But I'm the manager, so I don't get to say.
So it's about Chevrolet convertible example. I noticed for the BMW you switched the light, and for the Chevrolet you switched the antenna. But is it difficult to switch the light on the Chevrolet?
I'm not sure, but I know from the front end at least those are how do you say that? Bassi and Adriaan lampen. So those are a little bit difficult to replace. But
Retractable.
Retractable. Oh, nice. Now, of course, your question is perfectly valid. I think what's behind your question is you're making an incorrect and unfair comparison. Of course, it was just to make a bit of a joke. Get some lightheartedness in this very codey presentation.
All right. I saw a question down, but here we have another.
Talking about pure functions. So I have a complex code base and I want to purify my functions or the functionality. How deep should I go every time, and how can we do it gradually?
Yeah, you should start by reading the Warhammer 40K manual. Where do you start? So we recently got through something like this. So we've got a file on the top right where it's changed all the time. Everybody gets in there, and it's very complex. And we did start at kind of like on a random space there, just starting extracting some things. We had some idea of the various concepts that were stuck in that one file. I work in insurance, and there was an overlap of like sales and pre-sales concerns in there, as well as some retention concerns in there. So we knew that there were at least 2 different business problems being solved in that file. So that was a starting point for us to start massaging some of those out. We have had attempts at rewriting the whole thing. Those have all failed. So the only thing we did is we took 1 hour every week, Monday afternoon from 2 to 3, 1 hour of little bit tiny refactoring, and we have to commit and merge at the end of that hour. And it took a little over a year and a half, and we're now at the stage where the business concerns are isolated but still in the same file. 1 hour every week. I know it doesn't really answer your question, but there's like no generic answer for how do you untangle super complex code. Like if code is good, it looks all the same, and if it's bad, it looks bad differently everywhere.
Yeah, correct. Gradually, or 1 hour a week is the way. But then...
But merge. Not just commit, merge.
Yeah, immediately to production.
Yeah. No lingering.
Because for complexity, sometimes I see functions are like simplified, abstracted, but still I can go deeper.
Yeah.
So...
Yeah,
what is limit there, or like some guidelines, or how deep you can go with purifying your functions?
I mean, if the function itself is pure, that's more or less fine. I don't think you should be typically extracting much more than that. I'm sure you have guidelines on what is acceptable complexity or lines of code or all that kind of stuff. And then, if you really want, like the real answer is that I could give you is. The integration operation segregation principle, because that will talk to you about how can you actually make sure your functions do one thing.
Thank you. Any other questions? I saw somebody down at one point raise their hand. No? I do have a follow-up question myself. You mentioned that you do not like the mixed approach, and as a manager, you cannot argue.
I can argue. I can ask.
I'm curious if you could share with us what worries you in the mixed approach.
What worries me is that it's difficult for people to come in and know what's expected of them. And this is mostly true for less experienced developers. And it's like a little bit of a personality thing as well. I personally appreciate innovation, but someone else might appreciate consistency more. So from that perspective, depending on how stable the module is, I would prefer consistency over innovation.
All right. Thank you. Much appreciated. There's a short break, and